Welcome to another math session at Panther Math Corner. I am Dr. Howard, math teacher for Pasco County High School. Again, I want to welcome you to another session. This session will involve solving inequalities, and we're going to look at four of the properties of inequalities. This should be familiar because we from the last previous videos, I covered four properties of equality: addition, subtraction, multiplication, and division. This time involving inequalities, there are also the same properties referring to the addition, multiplication, subtraction, and addition properties and division, but in this case this is inequalities. Solving the inequalities using these properties, and I will demonstrate each of the properties, at least one in this video. The second one I'll do subtraction, the third one I'll do multiplication, and the fourth video I'll demonstrate division. Let's look at what you see before you. You see A is greater than B. Now, A is a form of a representation of the equation part, the left side, and then on the right side is your value. Then A plus whatever value that's next to the variable, where you perform addition. On this case, you add it on both sides. This should be familiar because when you have an equation like x plus 5 equals to 4, you would subtract. If you had a subtract on both sides of the equation sign, if you had like x minus 5 equals to 6, you would add 5 on both sides. All right, so it's just showing you that demonstration. This is the property rules for each of the four inequality signs: greater than, less than, greater than equal, and less than equal. And we'll demonstrate it. And you can see that when I demonstrate at least some of the inequality signs, you'll see it'll apply for this particular property, addition property. Let's take an example. B minus 2 is greater than negative 9. Okay. All right, using the addition property, look, you have B minus. So this represents your A, okay? And this represents your B, all right? Now, when we use the properties, we're using the addition property, adding a equal quantity of opposite sign on both sides. This becomes your C. All right, that represents your C. And if you're looking at these inequalities, C plus some C. So you're actually adding a equal quantity to the existing equation for the original equation. So this causes this to cancel. So you have bring down your B, and then you bring down your inequality sign, which is greater than. All right, and then this is negative 9 plus 2. Opposite signs, more negatives than positives, so you have negative 7. So your answer is B. Wow, let me make that B better. Okay, B is greater than negative 7. Now, let's graph. All right, we're going to graph. All right, I'm going to make a shortcut on the graph. I'm going to look at negative 7 as our solution. All right, and I'm going to look at maybe 7. I'm going to look at both sides. All right, you don't have to graph like this, but this is just an easier way to show. Instead of writing, unit by unit for an interval of numbers, you can do the same thing. And also I'll make some changes on how I describe it. Now, here's the thing. When you have less than or greater than, that means that less than or greater than will be an open circle. All right. If you have less than, greater than, and less than, let me write that again. All right, sorry. So if you have less than equal and greater than equal, then the circle will be closed, meaning it will be shaded. All right. And if it's an open circle, it'll be unshaded. Okay, so know the difference. Now let's look at this. B is greater than -7. B represents any number on the number line that is greater than 7. And you want to draw a graph in the direction where those numbers are true. All right. So let's graph it with the open circle for whatever it is. And then we'll determine, excuse me. And then we'll determine which direction the interval will include these values, where B is greater than -7. So we can do like true and false. Let's take any number. Let's take -6. All right. Is -7 greater? Is -6 greater than -7? True and false. All right. Well, real. Yeah, that's true. -6 is greater than -7. All right. Let's go backwards. Is -8 greater than -7? That's false. All right. We know that because when you look at the number line going to the left, even though the numbers are higher, but they are lower in value. So -7 is supposed to be greater than -8, but not the other way around. So -8 is not greater than -7, but -6 is greater than -7. So it seems like we're going this way. So if we test it again, say like 0, is 0 greater than -7? And that is true. So that means that looking at the test using a series of values to plug in for whatever represent V, just to do a test of the numbers, we see that the numbers that are greater than -7 are going to the right. So your graph for the open circle will go to the right all the way. If you want to put an arrow at the end, that's fine. But don't stop. All right. So this represents that all the numbers that are greater than -7 is going to go towards infinity. This is what the graph should look like. Go towards infinity, cut it off right here, and no numbers if you want to put numbers there, but just keep it going. And that's what it means. Okay. All right. Let's do another one. I'm going to erase this. All right. Okay. M minus 3, which is less than equal to 5. All right. Again, we're going to solve using the addition property. We're going to use straight line method 2, which means that we're going to add both sides 3 on both sides of the inequality sign. Okay, bring down my M. This cancels because -3 and a +3 are canceling out, so they are of equal quality, but unlike signs with equal qualities will cancel. And then bring my sign here, which is less than equal to whatever the value is, 5 plus 3, which is 8. So M is less than equal to 8. So just think about all the numbers that are less than equal to 8. Which direction is it going? We'll see. So we'll graph it. All right. Now, we know that this right here will be closed because it's less than equal. All right. So it will be a closed circle using a shaded dot. So we're going to put 0, and let's put -8 on both sides here and put an 8 right here. And we know that it's going to be a closed circle shaded. Now let's recognize which direction. M is less than equal to 8. So think about what numbers that could represent M. For example, let's use some of the numbers and test it out. 7 is less than equal to 8. True or false? 7 is less than equal to 8, so that's true. Okay, is 9 less than equal to 8? True or false? All right. Is that a true statement or false? It's false. 9 is not less than equal to 8. It's not even equal, but 9 is not less than 8, so that's false. So that's telling you that 9 is on the right side, which would be going to the direction of past 8. But this statement right here, 7 is less than 8, that's true, although it's not equal to, but it's make it still true because 7 is less than 8. So that's on the left side of 8. So we're going to think that the direction of all the numbers that are less than equal to 8 is going to go to the left. All right, enjoy it right here. So these are the kinds of tests you can perform. And closed circle, it's exactly 8 equals less than equal to 8, and then it's going to the left of the number line. All right. Okay. All right. We'll do one more. We'll do one more involving a fraction. I'm going to erase this again. All right. You can always go back and check. All right. 1/4 is greater than y minus 1/4. And this is usually challenging for students with fractions. They don't like fractions, but we can still treat it like any other numeral involving inequalities, like with solving equations. Again, we got to get y by itself, so we add an equal quantity on both sides using the method 2, plus, which is straight line, plus 4 on both sides, plus 1/4 on both sides, excuse me. All right, 1/4 and a negative 1/4, positive and negative, they both cancel. Break down your y. Okay, that is greater than, all right, 1/4 plus 1/4, which is 2/4, and that is reduced to 1/2. 1/2 is greater than y. So y is any number that 1/2 is greater than y. So we can do true and false again, use statements. So let's graph it. Put your little interval. We'll use negative 1/2. You can use any numbers, but since it's a positive, I want to think about negative so that they're both sides. And what kind of circle will this be? This is open because it's less than or greater than. Since this is greater than, it's open, and if it was less than, it would be open. It doesn't have the line under it indicating that it would be equal. So open represents less than or greater than. Put an open over here. It's not shaded. So we need to determine which direction. So let's do the true and false. Okay, 1/2 is greater than 0. True or false? All right, that's true. 1/2 is greater than 0. All right, is 1/2 greater than 1? True or false? That's false. Now look at it. 1 is on the right side of 1/2, right? However, it's a true statement with 1/2 greater than 0, which is on the left. So that tells me that all the numbers after 0, the numbers before 0, excuse me, if we're going in the direction, all the numbers that are going to the left are less than 0. Because 1/2 is greater than 0, so we can assume that all the numbers going to the left are responding the same way. They are 1/2 is greater than the number, so it's not even greater than the number past 1. All right, if we look at it, so we have to assume that the open circle will mean that it will go to the left again. You can draw a little line. So that means that all the numbers that are greater than 1/2 are greater than 0 and greater than -1 and so on. Sorry, let me put this right here. Greater than -1. All right. And this could be some other fraction. All right. Okay. All right. I hope you enjoyed the video. This is Dr. Howard coming to you from Math Corner, Panther Math Corner. This is another math session. You have a great day, and I'll see you. See you next time, and we'll introduce subtraction property of inequality. Thank you very much.